Hello there, Angry Welshman back again. Now, this is a video that's almost embarrassing to make. I mean, this is secondary school, primary school level sort of science here that you can easily test for yourself. It's almost embarrassing to point this out because I thought Mr. Thrive and Survive, kind of prides himself on being quite an intelligent human being. But in this, he kind of conveniently leaves out certain aspects of shadows and certain bits of information. This guy bathes in ignorance. It's astonishing. However, let's just this video, as you probably know, is about the eclipse that's coming up shortly, which flat earthers have no model of at all, and quite frankly never will. But let's just carry on. Most of this video is just him doing many things, but I'm just going to concentrate on this latter half of the video. Okay, let's see what he has to say.
Correct? So why do we have this? Why
Because it's correct.
do we have this? We have this because their model falls apart when it comes to eclipses.
No, it doesn't. It's funny how you say it falls apart, and yet using the mathematics, the physics, and the science, we have predictions for eclipses, solar eclipses for the next 2,000 years or so, or maybe even more than that. That doesn't sound like a model that's falling apart to me. And the fact that this one was predicted quite some time ago.
The lie is exposed.
Oh, the lie is exposed. Flat earthers love that word, exposed.
These are not coming in at 90-degree angles.
They don't need to.
Does that look like 90-degree angles to you?
Let's put it this way, light in general. If you can't see the light rays, crepuscular rays coming through the clouds, right? Light rays just come at you. You can't tell what direction they're coming in. This diagram is just proving a point. It's just a way to visualize it. Stop trying to pull apart something that's irrelevant.
You? Do I have to put 90-degree angles coming off here so you can see it? I hope you can.
Where that penumbra shadows will look exactly the same.
See, these are not 90-degree angles. Hell, they have this converging at the Earth.
Which it does.
We're just past the surface of the Earth. Now, why are they doing this? They're doing this because they have a problem.
No, they don't.
Let's shift gears for a second. Let's talk about shadows, shall we? Let's look at this. A shadow. This is a fundamental rule of shadows. It doesn't matter if it's sunlight or if it's light coming from a flashlight or from a fire or from the moonlight or even from Venus. Venus and Jupiter sometimes are bright enough to where they can cause shadows. It doesn't matter what the light source is, guys.
It does, actually.
A shadow of an object is never smaller than the object. It can be the same size as the object, but it can never be smaller. It can be larger than the object. So, let's
I would like to point out here, and I think he goes on a little bit further, one second.
tap that again. The size of an object's shadow can only be the same size as the object or longer. If you don't believe this, the next time you're outside, it doesn't matter what the sun angle is, lift up your shoe. You will see that when you are close to the ground, that the shadow is about the same size as your shoe. The farther away you get, or the lower the angle of incidence, the larger the shadow will be. It's never smaller than the size of the shadow.
Now here is where he conveniently only shows us pictures of shadows from objects that are directly on the ground. Here's where he's very choosy and very picky on the information he wants to put out. He doesn't show anything else that I'm about to show you.
Cannot be. This is a fundamental rule.
Yeah, but you're missing out one very key fact of this.
Of light. It's just like water will boil at one standard pressure at 100 degrees Celsius. It will happen every time. There is no exceptions to the rule. Except
There is in this case, but you're conveniently missing one thing out.
science makes one. Because they can't explain the eclipse.
Yes, they can.
Just like they can't get the speed of the moon right.
Oh, and you can? I'd love you to fucking show it.
Let me show you something here. Here we're looking at sun coming down through the clouds and causing a shadow. Now the shadows are larger than the clouds themselves. You might say, no, they're not. They're the same size, but they're larger. Look at these two little small puffy clouds here. Look how big the shadow is on the ground.
Yes, but that's because in concordance with its distance from the ground, the clouds are still quite close to the ground. I mean, they're only a couple of miles up, not 250,000 miles away, which the moon is, and the sun is 400 times further away than that.
What they're showing here with the arrows is how you can tell where the sunlight is coming from. There's another thing we're going to get into with diffusion, not in this video, but the further away the light source is from the object, the more diffuse the shadow is.
Yes, which is actually a point that you should have addressed in this video, which is what the eclipse is getting at.
You would not have a sharp shadow. The moon in the lunar eclipse, if the moon is causing the shadow, it's very sharp, isn't it? Yes, it is. That's
Yes.
how they show it. That's how we see it. Anyway, here's the clouds. Let me show you one more example. Here's the same thing we're seeing, except in diagram form.
Again, the clouds are quite close to the ground in accordance with distance.
The shadow of the object cannot be smaller than the object itself. Can you see that?
Yes, but again, you're not introducing this diffuse shadow thing that you want to leave for another video. You need to be talking about that in this video.
It's impossible.
You know, the diffuse thing, you know, penumbra is an extremely important part. I cannot understand why you've decided to leave it out of this video.
So if you wanted to measure this shadow right here, that is, see, no matter where you are here, if you're at this point on the ground or at this point on the ground or in between, the sunlight is completely blocked out.
Not really.
As soon as you leave this shadow, you start seeing the sun again, correct? Same thing works with the eclipse. How big is this cloud? Well, if you measure the distance from here to here to find out how wide the cloud was, you could say, well, let's just say this was 50 feet. You could say the cloud was 50 feet wide or less. It cannot be more.
Again, and you're missing your diffuse argument here.
Because the shadow is always the same size as the object or larger. Make sense? Okay. So let's take a look at that. Remember, keep that in mind. The moon.
Here he talks about the diameter of the moon and everything.
Alrighty, can we do that? Yeah, let's do that. Here's what I'm interested in right here. The moon's mean radius is 1,079.6 miles or 1,737.5 kilometers. Double those figures to get its diameter, 2,159.2 miles. The moon's equatorial circumference is 6,783.5 miles. So, what we want here is we want the diameter. The diameter would be the distance across from here to here.
Yes.
And the same from here down to the bottom, correct? How far wide apart is it? This should tell us how wide the shadow, okay, on the Earth.
And the shadow is that wide or larger, but again, you miss out a fundamental part which you conveniently want to leave for another video.
Should be cast by this. How can we tell? So, the diameter is 2,159 miles. We'll knock off the point too. 2,159 miles.
So skip for a second.
In the solar eclipse. So let's take a look and see what we're going to come up with on the eclipse day. Guys, we are going to eat this eclipse for breakfast, lunch, dinner, brunch, snacks. This is totally going to blow away the globe model when
No, it's not.
we get done with this. This is already going to do it right here. You see this path, guys? This is about 70 miles across. 70 miles across. So,
Forgetting your little thing that you've conveniently left out.
according to this, and according to the laws of science and the physics of light and shadow,
Which you seem to have forgotten about a few things.
the moon can be no bigger than 70 miles across.
Bollocks.
Because the shadow has to be the same size or larger than the object. Has to be. But, guess what? Because it's not, they come up with this bull crap.
And it's not bullcrap, and I will show you why. Well, let me just leave him continue talk for a second.
Here. That's why they come up with this lie. This is why the only time in the history
Albeit this is a very simple rendition of it, but, you know, never mind.
of the world that sun rays do not come off at 90 degrees and strike the earth is during eclipses. So we have a problem here, don't we? Yes, we do. All of a sudden, physics once again ceases to work. Not
In your mind it does, but in reality, no.
only do we have the moon that should lap the sun twice a day,
On its orbit, no, because its orbit is not a perfect circle. It's elliptical and goes through a bit of a wobble.
moving twice as fast this way, and it doesn't. The moon actually loses against the sun each day. We'll get into that in another video.
Oh, how convenient.
But we've only got a 70-mile wide shadow.
No, we don't have just a 75-mile wide shadow.
Period. That means the moon, according to science, according to the physics of light, can be no wider than 70 miles. So we're a little over 2,000 miles off, science is, on the size of the moon.
Right. Here's where I get into my point here, okay? He's conveniently left out the penumbra and umbra shadowing systems here, okay? Which you get things like this. Okay, this is what you show in the picture. This is what he claims to be bollocks. Okay? And this is simple stuff, guys, that you can easily sort out in a classroom or in your bedroom. I don't have any means to record any of this. I have no camera or source of light. I don't have a torch or anything on me at the moment. But look, he claims in his own words, right, a shadow can never be smaller, right, than the object. Well, let's look at this. See? Now, this is almost exactly like the very diagram that he claims is bollocks. Right, there we go. Okay, you see the shadow getting tiny there? Okay, there we go, look. Large source of light, the umbra shadow, which then goes off into a small point. So let's just basically put into perspective the Earth will be about here in terms of, you know, scale, and cast of quite a small shadow, much like what it's showing here, and much like what it's showing on the maps. I mean, look, this is something different again. It's got two sources of light, but we'll think that. See how the shadow goes into a small point. This is what's being cast on the Earth. This little small bit here. If the moon was closer, it'll be bigger. Now he claims that the shadow of the moon is only 70 miles wide, which is false. I'll get that in a second. See, look, you can get, these are from old books that you can sort out all of your things from. See, look, close source of light. Now, if that was further away from a larger source of light, the umbra would be smaller. As it shows here. Sun, object, small point of light, umbra, penumbra. Okay? It's just as simple. I mean, this is almost embarrassing to point this out. Okay, like this picture, as I said a moment ago, is pretty much almost exactly demonstrating exactly what he claims is bollocks. Okay, now what I'd like to point out is that he conveniently leaves out the penumbra shadow, which, like this video is pointing out. This shadow around here. This shadow is also cast. So I would like to point out that it's not just the people under this red line that experience the shadow. The shadow is all of this, right? All of this wide, goes in a big circle like this, and then everything goes to normal. These people are in complete darkness. These people are under partial darkness because of where they are. And if you measure this, this is probably matches, or even greater than, the diameter of the moon. I cannot understand why you conveniently miss this shit out from your video, you deceiving little shitbag. The shadow is not simply 70 miles wide. Its umbra is 70 miles wide, in this case, but its penumbra is far, far, far larger. So no, this is not bollocks. You just can't wrap your fucking head around it. When little experiments like this and this prove that this is correct, it kind of blows everything out, doesn't it? I mean, geez, let's see if I can find other examples. You know, let's have a look. There we go, something else. Look, there's the umbra. Things to a point. That's probably got two sources of light there. But then again, look, see the dark umbra bit is tiny. Look at this. See how the but then her arm is very close to the wall. But just see how the umbra is far narrower than the penumbra. I mean, there's a ton of things you can do. You can do this experiment. But like I said, the object has to be a fair distance away from the wall or object that is casting its shadow onto for you to get mainly a good penumbra and umbra shadow. I mean, if you just put your hand next to a light, the further you move your hand away from that light, the smaller the umbra is going to get. But the bigger the penumbra is going to get, as it shows here. See, the penumbra goes wide, like you claim in your video that the shadows get bigger, never smaller. But as you can clearly tell here, the shadow does get smaller. I mean, I don't understand why this video needed to be done, but it's. I mean, I'm not a scientist. I you know, compared to most people on here in this kind of topic, I'm a fucking idiot. But even I'm able to point this shit out. The fact that he conveniently leaves out all of the interesting stuff that prove him wrong. But yet Flat Earths are very well known for doing that, aren't they? I mean, you look at some of these things, right? Here's the eclipse. These things, there is probably diagrams here that show where the penumbra is. All these are showing is where you need to be, you know, directly underneath to see a full eclipse. Any further out, you won't get a full. You only get a partial one, but you'll still be under some shadow. I mean, show. See, we are. Look, here's a better one. Here's the penumbra. You know, I don't think the penumbra will be that large. Or maybe it's very slight penumbra, I suppose. Maybe the distances do work out. But I'll leave other people to calculate that. I mean, look, this one shows it. This one shows the umbra and the penumbra in different scales of intensity. And there we have it. So that just completely blows MrThriveAndSurvive's video completely out the water. A little bit angry there in the middle, which everybody likes, I suppose. So that's me again. Please like and subscribe. Leave a comment down below. give me any suggestions of any YouTubers that I should look at and do responses to if you like my content, and I'll see you again.